A great white shark washes up on a beach 5 meters of the most feared animal in the ocean, and the body is almost perfect. No missing chunks, no shredded flank, one clean opening near the pectoral fins, and the liver is gone. Nothing else was taken. This is not a shark that lost a fight. This is precision. Something in that water knew exactly where that organ sat and how to reach it. And the other sharks, the ones still alive, did not fight back. They left the coast. The killer is only the first layer of the lie. Before we work out what opened that shark, there is an older problem to deal with. Somebody told you this animal was the king of the ocean. You believed it. So did I. So did a lot of people who spend their working lives standing on boats above it. So ask the obvious question: where did that ranking come from? Who ran the test? What did the great white beat and when? Nobody ran a test. That is the first thing to understand, and it is more unsettling than it sounds. The crown was not measured. It was handed out. Think about what actually appears in your head when someone says great white. It is not data. It is a shape. Gray on top, white underneath. A hard triangular fin slicing a flat surface. A mouth that opens like a trapdoor in the floor of the world. A black eye rolling back at the moment of contact. Most people do not picture the animal at all. They picture the poster. A swimmer near the surface, small and unaware, and beneath her a shape rising with its mouth already open. That image did something to a fish that no scientific paper has ever managed. It made a species mean something. And here is where it stops being a story about a movie and starts being a story about a hole in our knowledge. The image arrived before the information. In the mid-1970s, when the great white became the most famous fish on the planet, almost nothing was known about how it actually lived. Not where it went when it left a coastline, not how deep it went, not how long it lived, not how often it needed to eat, not what it did for the majority of its year. The most feared animal in the ocean was, in scientific terms, a stranger. That gap matters far more than the film does, because a vacuum does not stay empty. Give people an animal with a body that large, teeth that visible, and a life nobody can follow, and the empty space fills with the only material available: imagination. And imagination has a preference. It never fills the gap with a slow, energy-starved traveler doing arithmetic with its own calories. It fills the gap with a monster. Look at the teeth, because the teeth are where the reasoning goes wrong in a way that is easy to miss. Serrated triangles, blade-edged, arranged in rows, replaced continuously through life, so that a worn tooth is simply pushed aside by the next. All of that is real. All of that is genuinely alarming to hold in your hand. But watch what we did with it. We looked at the weapon and inferred the rank. That is not biology. That is heraldry. A tooth tells you what an animal is able to cut. It does not tell you what it eats, or how often it succeeds, or whether it wins, or whether something larger is watching it from 300 meters away and has already decided how the next 20 minutes will go. Weapons are not evidence of dominance. A knife in a drawer does not tell you who runs the house. The silhouette pulls the same trick. That torpedo body with the stiff tail and the crescent fin reads as pure aggression, and it is one of the most efficient shapes evolution has ever produced. But efficiency of shape is a statement about travel, not about rank. That body is not built to prove anything. It is built to solve a problem, and we will get to the problem because it turns out to be the most expensive problem this animal has. Now, the harder part, the part that is not about culture at all. Where did we actually watch these sharks? Almost everything the public has ever seen of a living great white comes from a handful of places on Earth, and from a narrow window of weeks in each of those places. Certain coastlines, certain seasons, certain islands where seals haul out in thick, noisy, oily crowds, and the sharks arrive because the food arrives. That is where the cage boats go. That is where the cameras go. That is where the water is clear enough, shallow enough, and reliable enough to film anything at all. And that is where you get the breach, the famous one. A shark going vertical, clearing the surface with a seal in its jaws, spray hanging in the air, everything about it looking like the myth confirmed. That footage is real. Nobody faked it. The problem is not the footage. The problem is that we took the most violent, most photogenic sliver of this animal's calendar, filmed at the one location and season where it does the one thing that matches the legend, and we called that the animal. Imagine somebody built a documentary about human beings using only footage shot inside a boxing ring. Every frame is honest, every punch is real. The conclusion would still be a lie because you never see the eating, the sleeping, the waiting, the traveling, the failing, the enormous, unglamorous machinery of staying alive between fights. We built the great white out of ring footage. And then it would leave. That was the part nobody could do anything about. The season would end, the seals would thin out, the sharks would go, and the science would simply stop. Not because anyone was lazy, because a shark that swims out into open blue water is gone. There is no road, no vantage point, no way to keep a large fish in view across an ocean basin. Follow one for a day, and you have burned a boat's fuel to learn almost nothing. So the record had a shape to it. Sharks appear near seals. Sharks kill seals. Sharks vanish. Sharks reappear near seals. Read that sequence back and notice what it makes you assume. It makes you assume the vanishing is a gap in the story. It is not. The vanishing is the story. The seal hunting is the interruption. That did not become obvious until scientists stopped trying to watch the shark and started making the shark carry the equipment. Acoustic tags that ping to receivers, satellite tags that pop off, float up, and transmit what they recorded. Suddenly, the parts we could never follow started reporting back on their own. The first surprise was not a small detail. It was a direction. And once that data started coming in, the seal-hunting shark we had been filming for decades began to look less like a portrait and more like a coincidence. Hold that. It comes back. Because here is what should be said plainly. And it is the reason this is not a story about scientists being stupid. Apex predator is a real term. It means something specific. It describes an organism sitting at the top of a particular food web in a particular place that isn't routinely eaten by something else. Used carefully in a defined system, it is useful. It was never meant to be a title. It was never meant to travel from a bay to an ocean, from a season to a lifetime, from a diagram to a species. The old picture was not foolish. It was assembled from the only evidence anyone had, and the evidence was a coastline in autumn and a mouthful of blades. But every crown in history has one property in common. If it can be given, it can be taken. And there is one more thing worth sitting with before we go back to the beach, because it reframes everything you think you know about being afraid of this animal. For 50 years, the scariest thing about the great white was never the shark. It was the size of the space around the shark, the part of its life that no camera reached, filled in by us with the worst thing we could think of. The monster was a data gap. So when a body washes up on the sand, opened once, drained of a single organ, and the sharks that survived the night abandon a coastline they had used for generations, the question is not simply who did it. The question is what else was in that gap the whole time, while we were pointing the cameras at the seals. The famous part of this animal is the mouth. The important part is not. Put a great white next to almost any other fish in the sea, and something about it is quietly wrong. Touch the water it lives in. off a cold coastline, in a gray swell, in temperatures that make a wetsuit non-negotiable. And then imagine reaching inside the shark, deep, past the skin, past the pale outer muscle, into the dark red block of tissue packed along the spine. It is warm, not room temperature, not slightly above the sea. Warm enough that the difference from the surrounding water is something you would notice on your hand. That should not happen. A fish sits in water. Water strips heat out of a body hundreds of times faster than air does. And every breath a normal fish takes runs its blood straight through the gills. Thin, exposed, built to exchange gas with the sea. Anything warm arriving at a gill leaves cold. That is not a design flaw. That is physics. For most fish, body heat is a fantasy. The great white broke it anyway, not by generating some special furnace, by refusing to let the heat leave. Bundled inside its body are structures where arteries and veins run against each other in dense braided masses, thousands of tiny vessels interleaved. Cold blood coming in from the gills passes directly alongside hot blood coming out of the working muscle. Heat crosses over. The cold blood is warmed before it reaches the core, and the warm blood is stripped of its heat before it ever reaches the gills, where it would be lost. It is a heat trap, and it is so effective that the shark's swimming muscle, its stomach, its eyes, and the tissue around its brain can all run above the temperature of the sea it lives in. Now, the obvious reaction is that this is an upgrade. Warm muscle contracts faster and recovers faster. A warm gut digests faster. Warm eyes and a warm brain process a moving image faster, which in a cold ocean means seeing a fast animal as a fast animal instead of a blur. And it lets the shark stay powerful in water that would slow a cold-blooded fish to a crawl. Every one of those is real. So the story writes itself. Warm shark, better shark, king of the ocean. Except that is not how bodies work, and it is not how this one works either. Heat is not a feature. Heat is a bill. Every degree of warmth in that muscle came from burning fuel, and fuel means food, and the sea does not hand out food. A cold fish can sit on the bottom, drop its metabolism to almost nothing, and simply wait out a bad month. Its engine idles. It costs almost nothing to exist. The great white has no idle. The heat trap runs constantly. The muscle stays warm whether it is hunting or drifting or crossing empty water for weeks. And on top of that, this is an animal that mostly cannot stop moving. Water has to be driven over its gills, and its body has no gas-filled bladder to hold it up. Stop swimming, and you stop breathing well, and you start sinking. So the shark pays a second bill on top of the first, every hour, forever, which turns the whole picture inside out. This is not a body built to kill. Killing is easy for it. Killing was never the problem. This is a body built to afford killing. And that is a far harsher engineering brief because now the shark is trapped in an equation. It has bought speed, sight, digestion, and cold water access with a permanent debt. And the sea has to pay that debt or the shark dies. Not dramatically, not in a fight, just quietly from arithmetic, which means the shark cannot eat like a normal predator. Think about what a fish is as food. Lean red and white muscle, a skeleton, some organs. Gram for gram, it is decent fuel and no better. Now think about what a seal is, wrapped in a thick layer of blubber under the skin. Fat carries roughly twice the energy per gram that lean tissue does, and blubber is close to a pure block of it. The seal is not prey. The seal is a battery. And suddenly, the thing everybody films at those islands stops being a horror scene and becomes a transaction. The shark is not attacking because it is savage. It is attacking because it is expensive. And blubber is the only currency in the shallow sea that covers what it costs to be this animal. A great white eating fat is a great white balancing its books, Watch that famous strike again with the numbers in your head, and it changes shape completely. The approach from below in dark water, the vertical rise, the single enormous impact. That is not aggression. That is an animal that cannot afford a chase. Every failed pursuit burns fuel it may not get back. So it spends everything at once, in one collision, from the one angle where the target cannot see it coming. Get it right and the debt is cleared for a while. Get it wrong and you have just paid for nothing. The hunter is not a killer with a mouth. It is an accountant with a body it can barely maintain. So where does it keep the money? Not in blubber. Sharks do not have blubber. It goes into an organ almost nobody thinks about sitting in the belly of the animal. That is not a small internal component at all. In large sharks, the liver is enormous. In some species, it can account for a substantial share of the animal's entire body weight, filling much of the body cavity as a heavy, soft, oil-saturated mass. And the oil in it is unusual. It is light, lighter than seawater, which means the liver is doing something no textbook diagram of a shark ever bothers to make dramatic. Every bony fish you have ever seen has a swim bladder, a gas pocket it inflates and deflates to hover. The shark never evolved one. A shark is denser than the water around it, and physics does not negotiate. So instead of a bag of air, it carries a tank of oil. And that oil is the reason a 2-ton animal can hang motionless in a current instead of falling to the bottom like a stone. Now hold both facts at the same time, because this is where the animal becomes genuinely strange. That same organ is the fuel tank. The blubber it eats gets converted and stored there as oil. So the liver is simultaneously the thing that keeps the shark from sinking and the thing that keeps the shark from starving. Buoyancy and energy are the same substance, held in the same place, in one soft, undefended mass, which sounds like elegance. It is not. It is a design with a single point of failure. When a great white goes weeks without eating, and it does routinely because the sea does not lay out seals on a schedule, it burns the liver. It draws down the oil. And as the oil goes, so does the lift. A starving shark does not just get weaker, it gets heavier. It sinks more, which means it must work harder to stay off the bottom, which burns more oil, which makes it heavier still. Hunger, in this animal, is a loop that tightens. That is the true cost of the warm machine. Not that it needs a lot of food, but that its reserve, its flotation, its entire margin of survival has been concentrated into one organ. Everything this shark has ever earned is sitting in a single soft container behind its pectoral fins, and its exact location is not a secret. It is anatomy. Any animal that has opened one shark knows where it is. We have spent 50 years describing this species as the ocean's most dangerous body. Look at it honestly, and it is the ocean's most valuable one. A warm, fast, powerful animal that has to keep converting the fattest prey it can find into a low-density oil and store all of it in one place permanently, because that oil is the only thing between it and the seabed. Which brings us back to a body on a beach. 5 meters of predator, intact, unbitten, unmauled, and lighter than it should be because the one part that mattered had been taken out through a single opening and nothing else was touched. That was not a kill. That was a withdrawal. A dead shark is not a mystery. That is the first thing to get straight because it stops this from becoming a ghost story. Sharks die constantly. They die of age, of infection, of parasites, of injuries that went wrong, of being born in a bad year. They die in nets, on lines, in beach barriers strung across surf breaks. Most of it happens out of sight and sinks, and the sea takes it apart in days. On the rare occasion a large one comes ashore, the default explanation is boring and usually correct. Something went wrong, or somebody's gear did. So when great whites started appearing on the sand along a stretch of South African coastline, the first reaction was not alarm. It was routine. Somebody drives out, somebody takes photographs, somebody cuts the animal open to find out what killed it. Then they looked at the bodies. Picture what you expect. A big predator that lost a fight should look like it lost a fight. Torn flanks, missing fins, a gouged tail, chunks gone from the belly, scavenger damage where the gulls and the crabs and everything with a mouth arrived to collect. Death in the ocean is not tidy. It is a demolition. These animals were not demolished. They were intact, gray skin unbroken across the back, fins attached, tail whole, eyes still there. From 20 meters away, you would think the shark had simply stopped working and drifted in. You have to get close, and you have to get low, and you have to look at the underside, and then you see it. One opening. Between the pectoral fins, a single wound on an otherwise perfect animal. And when they went in through it, the body cavity was wrong in a way that takes a second to process. Because the liver, that enormous, oil-heavy mass that in a shark this size is not an organ so much as a compartment, filling a huge share of the space inside, was gone. Not damaged, not partly consumed. Gone. And the rest of the animal was still there. Stop and hold the image because the horror in it is not gore. It is neatness. Consider what it takes to do that. This is a 5-meter animal with a body that can break a seal's spine on contact. It is not a fish you subdue by accident. And whatever handled it did not tear it apart to find what it wanted. It made one entry at one location and removed the single most valuable structure inside, and then left everything else, the muscle, the heart, the guts, the meat, that any hungry thing in the ocean would take first, lying on the sand for the gulls. That is not hunger. Hunger eats what is nearest. That is selection. And it kept happening. Not once, in one strange incident that could be written off as coincidence. The same signature on multiple animals over time, on the same coast, same clean carcass, same opening in the same anatomical region, same missing organ. A single event is an accident. A repeated event with an identical pattern is a technique. Now go back to the two things we already know about that organ and watch them collide, because this is where the story stops being about a corpse and starts being about what the corpse proves. We know the liver is the shark's fuel tank. Everything it ever earned from every seal it ever hit, converted and stored as oil. And we know it is the shark's flotation. The only reason a dense animal with no gas bladder can hang in the water instead of sinking. Fuel and lift in one soft, undefended mass, which means that of all the tissue inside a great white, the liver is the richest thing in the entire animal. It is not muscle. It is not lean meat. It is oil. Concentrated, high energy. Exactly the kind of payload the shark itself spends its whole life chasing across an ocean. The great white built its body around collecting fat. Something worked out that the great white is fat. That reversal is the whole chapter, and it is worth saying slowly. This animal's strategy is to find the fattest available prey in the sea and convert it into stored oil. It succeeded. It got very good at it. And in doing so, it turned itself into precisely the thing it hunts, a swimming reservoir of exactly what it was designed to seek. The predator became the payload, which brings the uncomfortable question that the necropsy could not avoid. Not what killed it, where the wound is. Look at a shark's anatomy laid out flat, and the geometry is unforgiving. The liver sits forward and low in the body cavity, the shortest, cleanest route to it. The route that does not go through the thick swimming muscle along the back, does not go through the gut, does not go through the skeleton. is up from underneath in that soft zone between and just behind the pectoral fins, which is exactly where the opening was. That is not luck. You do not get to that spot repeatedly across different animals by thrashing. You get there by knowing. Whatever is doing this is not attacking a shark. It is opening a shark, and it is opening it at the one location where the good part comes out fastest. And now the picture inverts a second time, because we spent an entire chapter establishing that the great white's greatest vulnerability is running its liver down. Starve it, and it burns the oil. Burn the oil, and it gets heavy. Get heavy, and it burns more. That was the slow version of the problem. This is the fast version. Something found a way to remove 50 years of the shark's accounting in a few minutes through a single hole and walk away with all of it. The old assumptions had to go one at a time. Was it disease? Diseased animals do not develop matching surgical incisions. Was it fishing? Fishing damage looks like fishing damage. Hooks, net abrasion, cut fins, gear, there was none of that. Was it another shark? Sharks do not do this. A shark bite is a bite. It takes a crescent of flesh out of whatever it closes on. It does not enter a body cavity, extract one organ, and leave the surrounding meat untouched. And here is where honesty matters more than drama. We can say what the pattern is. We can say where the wound sits and what is missing, and that it repeats. What we cannot do is climb inside the head of whatever did it and declare the motive with certainty. Is it feeding on the richest tissue on purpose? That is the most reasonable reading of the evidence, and most people looking at these bodies think so. Is it also, or instead, some part of how the attack itself is carried out, with the organ simply being what comes out when you open an animal there? That is harder to rule out than it sounds. And in some of these cases, other organs have been reported missing too, which complicates any neat story about a single target. Keep the uncertainty. It is not a weakness in the case. It is the case. Because the one thing the pattern demands, regardless of motive, is knowledge. Anatomical knowledge. A working map of the inside of a shark, applied the same way, more than once, by something that had to have learned where to cut before it ever got there. So stand on that beach for a moment and look at what is actually in front of you. A scale bar and a person for size and a body longer than a car. The most feared fish on the planet. Every part of it that made it famous still perfectly intact. The teeth, the fin, the black eye, the whole silhouette that has been frightening people since before you were born. All of it useless, all of it still attached. And the only part that ever really mattered, the part nobody puts on a poster, taken out through one clean opening by something that knew exactly where to look. Rage would be easier to understand. Rage makes a mess. Rage takes the nearest thing. This was efficient. And efficiency is worse, because efficiency means somebody has done it before. So the question is no longer what happened. The question is, what has a body large enough to hold a 5-meter great white still, a mind capable of remembering where an organ sits, and the patience to take one thing and leave the rest? There is an animal in that water that fits, and the reason this story does not end when we name it is that naming it explains the bodies on the beach, and explains nothing at all about what the living sharks did next. The animal that fits has been swimming past us the whole time, and we gave it a nickname instead of attention: killer whale. Say it out loud and notice how harmless it sounds now. Black and white, curved fin, a face people put on lunchboxes. We taught this animal to leap on cue in front of children. We built an entire emotional relationship with it, based on the idea that it is intelligent and playful, and, this is the part that matters, that we understand it. We do not understand it. We understand a fraction of it, and the fraction we understand is the one that agreed to live in a tank. Start with the body, because the body is not a mystery, and it removes the first objection. A large male orca can approach 9 meters and weigh several tons. That is not a fish-sized advantage over a great white. That is a different weight class entirely. An animal that can outweigh a big white shark by several times over, moving in a body built by the same ocean, with the same demand for speed. And one thing the shark does not have: air, which means a brain that can be big and stay expensive, and never has to compromise with a gill. But size alone does not explain a single clean opening. Size explains overpowering. It does not explain aiming, because you have to be honest about what the beach evidence demands. It demands that something located a specific organ inside a body it cannot see into. That is not strength. Strength gets you a torn shark. What is on that sand is a solved shark. So how does an animal learn where a liver is? Not by instinct. This is the reversal, and it is the one that changes what kind of story you are in. Instinct is broad. Instinct says chase, bite, swallow. Instinct does not encode a diagram of the internal anatomy of a species that lives on the other side of a food web. Nothing is born knowing that. Which leaves the uncomfortable alternative. Somebody worked it out, and then told the others. That sounds like an overreach until you look at what orcas already do everywhere else on the planet, in plain view, with no controversy attached. Off certain coastlines, they hunt seals by charging a shoreline in a coordinated group to push a wave up the beach and wash the seal off the ice or the sand. In other waters, they herd herring into a tight ball with bubbles and flashes of white belly, then stun them with slaps of the tail. Elsewhere, they take marine mammals in silence, barely vocalizing, because their prey can hear them coming. Elsewhere again, they chatter constantly, because their prey cannot. Now notice what is strange about that list. Those are not variations in body. They are variations in method. Different populations of the same species with functionally the same anatomy, doing completely different jobs in completely different ways. And each population doing it the same way for generations. Every one of those techniques had to be invented once and then passed on. A young orca does not derive wave washing from first principles. It is taught, it follows, it watches, it fails, it gets corrected, and years later it does it too. That is not a metaphor. Techniques stay inside family lines. So do dialects. The specific calls one group uses that another group does not. So do preferences. Some orca populations eat almost nothing but fish and will ignore a seal swimming right past them. Others would never eat that fish, which means the correct unit here is not the species. It is the lineage. The knowledge is held in the group, and the group is where it survives. So take that machinery and point it at a shark. Elasmobranchs, sharks and rays, turn up in orca predation across multiple regions. Rays being taken and their livers removed. 7-gill sharks turning up with the same missing organ. Makos, blue sharks, deep water sleeper sharks. And back in the late 1990s, off the California coast, people on the water watched an orca kill a young white shark near the surface. A rare, documented, thoroughly unwelcome piece of information for anyone who had built a career on the Crown. That was treated as an anomaly. One event. Bad luck for one shark. But look at it now next to bodies on a South African beach with the same signature, and the anomaly stops looking anomalous and starts looking like the visible edge of something that has been running for a long time in places nobody was watching. And in South Africa, the pattern has a face on it. Not a myth, not a rumor. 2 adult males, identifiable on sight because their dorsal fins are bent over, collapsed to opposite sides. which is exactly the kind of individual marking that lets researchers track a specific animal across years and coastlines instead of guessing. Their presence has been repeatedly associated with these events, along the same stretches, at the same times. Two animals, identifiable, recurring. Here is what that does to the picture. Every previous version of this story had a species problem. Sharks versus orcas, one team against another, the sort of thing that ends up as a thumbnail. That framing is dead. This is not a species doing this. It may be a handful of individuals carrying a specific piece of learned knowledge, applying it repeatedly on one coast. The crown does not fit a species. It fits a technique. And a technique lives inside a few skulls, which is far stranger than a monster. A monster is fixed. You can measure it. A technique spreads. It has no upper limit and no obvious boundary, because it can be taught to whoever is swimming alongside. Now the mechanics, and here honesty matters more than spectacle, because this is exactly the point where invented drama would be easy and worthless. Nobody has a complete filmed record of every step of one of these events from start to finish. What exists is fragments, and the bodies afterwards. What we can say from the bodies is that the shark was controlled before it was opened. You do not make one precise entry into a thrashing 5-meter animal. Whatever happened, the shark was immobilized, or exhausted, or held first. And orcas hunting large prey work in coordination, which is the one way a group can shut down an animal that any single individual would struggle with. What we can also say is that the entry point sits at the shortest route to the target, and that this repeats. What we cannot say is the intention. Are they going in specifically for that organ every time, because it is the richest tissue in the animal? That is the most reasonable reading, and it lines up with the same species removing the same organ from other sharks and rays elsewhere. Is it partly a consequence of how you take apart an animal built like that? The soft underside being the way in, and the liver simply being what is behind the door? Harder to rule out than people admit. And other organs have been reported missing in some of these cases too, which is a loose thread that has not been tied off. That uncertainty is not a hole in the case. It is a warning about the level we are operating at. We can read the wound, we cannot read the reason, and the gap between those two things is precisely where 50 years of confident nonsense about the ocean's top predator came from in the first place. But strip the story back to what is undeniable, and it is still bad for the crown. The animal we called the ocean's apex predator is being killed by something that hunts using an idea. Not a bigger tooth, not a stronger bite. A method held in a family, applied to a target whose anatomy has been mapped by experience rather than instinct. And an idea has a property nothing biological has. It does not need a generation to change. A shark's body improves over evolutionary time, in increments, across thousands of years of failure. A technique can be invented in one afternoon and taught by the following season. The shark is playing a game measured in millennia. The thing taking its liver is playing one measured in memory. So we have a killer. We have a method. We have identifiable animals. Case closed, crown transferred, roll credits. Except the bodies on the beach were never the strangest part of this. Because after these events, people watching those coastlines noticed something in the data that had nothing to do with the dead sharks at all. It had to do with the living ones. The ones that were never touched. The ones that were fine. They were not there anymore. An apex predator does not have anywhere to go. That is what the word means, if it means anything. It is the end of the line. Nothing above it. Nothing to run from. Nowhere it needs to leave. So watch what the great whites did. South Africa, False Bay, and the waters around Seal Island. One of the most reliable places on Earth to see this animal doing the thing it is famous for. Not a rumor, not a rare sighting, an operation. Boats went out. Cameras went out. Researchers with years of accumulated sightings. Individual sharks recognized by their fins the way you recognize a face. The seals were there. The season was there. The sharks came back every year the way weather comes back. Then the orcas arrived, and within a very short window, we are talking about a scale measured in hours, not seasons, the sharks were gone, not thinned out, not fewer, gone from the site. Sharks that had been tracked in that water, tagged, individually known, moved out, and did not come back for weeks. In some cases longer. In some cases, the aggregation that had defined that coastline for decades essentially stopped functioning. Hold that against everything you have ever been told. This is the most feared fish in the sea, in the middle of the richest feeding opportunity available to it, sitting on a food source it needs, and it left. It abandoned the seals. It abandoned the territory. It abandoned the one behavior that got it on every poster and in every nature film for 50 years. Because something showed up. Now be careful, because this is exactly where a bad version of this story would sprint ahead of the evidence. The honest position is that these events sit alongside each other in the record, and the correlation is strong, repeated, and hard to explain away. Orca presence, then shark absence, over and over. But there are other things happening in that ecosystem at the same time. Fishing pressure on the sharks and their prey, long-term population change, environmental shifts that were already underway. Researchers argue about how much weight to give each factor. Some think the orcas triggered a collapse. Others think they accelerated something already sliding. That argument is still live, and you should not let anyone tell you it is settled. But the fine-scale detail is what makes it impossible to dismiss, because the tags do not just say the sharks stopped being seen. Tags say where they were, and the departures cluster tightly around the arrivals. Sharks that were in the bay, immediately not in the bay. That is not a slow ecological trend. That is a reaction. And here is what makes it genuinely unnerving. They did not need to see it happen. Some of these sharks were nowhere near a kill. They did not witness anything. They were simply in the water when the information arrived, and then they were not in the water anymore. Which raises a question nobody can fully answer. What did they detect? The best available reading is chemistry. Water is not empty. It carries a rolling record of everything that has happened in it. Blood, tissue fluid, the specific chemical signature of a torn open animal of your own species. The shark's nose is not a nose. It is a pair of channels that funnel water across sensory tissue built to read dissolved molecules at concentrations that make no intuitive sense to a land animal. It does not smell the sea. It reads it. So a shark 30 kilometers down current from an opened conspecific may be swimming through the news. Not a rumor, a document. And it leaves. Which sounds like a neat answer until you sit with the implication, because now the water itself has become a threat map. The shark is not fleeing an orca. It is fleeing information about an orca, and there is no way to unlearn that once it is in the water. The chemistry does not have to catch you. It only has to reach you. Now here is the reversal that should have ended the crown by itself, and it has nothing to do with cowardice. Running is the correct decision. We established what this animal is. A warm engine with a permanent bill. Every gram of it paid for in blubber. Every gram of that stored as oil in one soft organ, behind the pectoral fins. It has no reserve outside that organ. It has no armor. It has no way to make its liver less valuable to something that has already worked out where it is. Fighting is not a strategy available to it. Fighting is spending the entire savings on a hand you cannot win. Even winning costs. A wound on an animal that must swim constantly to breathe is not an inconvenience. It is a slow bill it may not be able to pay. There is no scenario where a great white trades blows with a coordinated group of animals several times its mass and comes out ahead. So the shark does the only mathematically sane thing. It leaves the coast, eats nothing, burns oil, gets heavier, and lives. Understand what that means. The seals were not the shark's territory. They were the shark's income, and it walked away from all of it, immediately, without hesitation, because staying was worse. The great white is not a king who ran. It is an animal that has always been running, and we simply never had a camera in the right place to see the thing it runs from, which reframes the fear. There is a concept ecologists use, the landscape of fear. The idea is that a predator does not only shape a system by eating, it shapes it by existing, because every animal beneath it is constantly deciding where not to be, when not to be there, and what to give up in exchange for staying alive. The prey pays a tax in lost feeding, lost territory, lost time. We have used that concept for decades to describe what great whites do to seals. Nobody thought to check whether the shark was living inside one too. It is. That bay, the one everybody films, the one that looks like a hunting ground. For the shark, it is a risk zone that it enters when the payoff is high enough and evacuates the moment the numbers change. It was never a throne. It was a place the shark could afford to visit until it couldn't. The shark was never at the top of its own bay. It was in the middle of something, making the same calculation the seals were making, one level up. And now something worse, because this is where the story stops being about individuals. Watch what happens to the site. The sharks leave, and the seals, the ones that spent every day of their lives compressed into a routine built entirely around not being killed, launching off the island in tight groups at dawn, sprinting the gauntlet, hugging the shallows. Nothing is hunting them anymore. So they change, they spread out, they use water they never used, they stay longer, go further, relax. That looks like a happy ending? It is not. It is a system with its regulator removed, and every animal the seals eat is now on the wrong end of a change nobody voted for. We will come back to that, because the size of that effect is genuinely disputed, and I am not going to pretend otherwise. But hold the image. A coastline where the fear evaporated, and everything underneath it rearranged. 2 orcas, possibly a handful, carrying a technique, and an entire ecosystem structure moved. That is the part that should bother you about the word apex. It was never describing a strength. It was describing a position on a chart. And a position can be vacated in an afternoon. But there is a much larger problem hiding in all of this, and it has been sitting in plain sight since the first sentence. Every bit of this story, the seals, the island, the season, the boats, the departure, takes place in a strip of water a few kilometers wide. That is where we watch. That is where the tags get read and the fins get photographed and the crown got handed out. The shark leaves. It goes out past the shelf, into open blue water, and it stays out there for months. Not weeks, months. And for most of the history of this animal, that part of its life was simply a blank space in the record. So when it left False Bay, it was not disappearing. It was going back to work. And what it does out there, thousands of kilometers from any seal in the emptiest water on the planet, diving to depths that make no sense for an animal we insisted was a coastal killer, is the part that finally breaks the myth for good. Because the seal hunting we filmed for 50 years, that is not what this animal does. That is what it does on holiday. Everything you know about this animal was recorded within sight of land. Sit with that, because it is not a small caveat. It is the whole foundation. The breaches, the seals, the cage footage, The fin at the surface, the 50 years of accumulated certainty about the ocean's top predator. All of it filmed in a shallow ribbon of water you could swim across. And then, every year, the sharks went out past the shelf and the record simply stopped. For decades, the honest answer to where does it go was that we had no idea. Not a vague idea. None. It went into blue water, and the science ended at the horizon. So people assumed. And the assumption was reasonable, which is why it lasted. A big, warm predator that needs blubber lives, where blubber lives. Seals are coastal. Therefore, the shark works the coast, maybe moves along it, maybe shifts to another seal colony down the shore. Sensible. Cheap. Wrong? The only way to find out was to stop chasing the animal and make it file a report. That is what pop-up archival tags do, and they are one of the quiet miracles of modern ocean science. You attach a small unit near the dorsal fin. It does not transmit. It just records depth, temperature, light levels, every few seconds, for months, while the shark does whatever a shark does. Then, on a date set in advance, a corroding link lets go. The tag floats up, breaks the surface, finds a satellite, and dumps everything it saw. You do not follow the shark. You wait, and the ocean posts the file back to you. And when those tags started popping, the first shock was not in the data. It was in the location of the tags themselves. They were coming up in the middle of nowhere, not down the coast, not at the next island, out past the shelf, past the productive green water, out in the open blue, where there is no bottom to speak of and no seals for 2,000 kilometers in any direction. Sharks tagged off California were surfacing halfway to Hawaii, in a patch of the Pacific with nothing in it worth a second glance. Some kept going and reached the Hawaiian Islands outright, and they were not passing through, they stayed. Months out there. Long enough that the offshore period is not an excursion from their life. It is the bulk of it. The coastal hunting season we built an entire species reputation on is a fraction of the animal's year. Then the Indian Ocean produced something that made the Pacific tracks look modest. A white shark tagged in South Africa turned up on the other side of an ocean, off Australia, and then came back, not drifting, crossing in something close to a straight line, and then returning to the same region it started from. A round trip on the order of 20,000 kilometers, completed inside a year. That is one of the longest journeys ever documented for any fish, and it was made by the animal we had confidently filed under coastal ambush predator. Now look at what that route actually is. It is not a migration through rich water. It is a crossing of the marine equivalent of a desert. Open ocean, thin on life, no shelf, no seals, no shelter, nothing to hide behind and nothing to hide from. Every kilometer of it burns oil. The shark has no gas bladder to hold it up, no way to idle, no option to stop. It swims, constantly, for months, getting lighter in the liver and heavier in the water, across a stretch of sea that offers almost nothing. Why would anything do that? Hold the question, because the tags had a second surprise and this one is worse. When you unpack the depth record from those offshore months, you expect a line near the surface. A big fish crossing an ocean should stay in the warm top layer where swimming is cheap and the sun is. The line does not do that. It looks like a saw blade, down and up, down and up, down again, hundreds of meters each time, repeated dozens of times a day for weeks on end. In the offshore zone, the pattern gets so relentless, it stops looking like travel and starts looking like a job. A shark dropping into cold black water, coming back, and doing it again, over and over, in a place with no seals and no coastline, and no visible reason to be there at all. And the depths are not modest. These animals go far beyond where sunlight is useful, down into water that is cold and dark and pressurized, well into the hundreds of meters, in some records approaching a kilometer, which is an appalling place for this specific body to be. Remember what it costs to be a great white. The whole War Machine architecture exists to keep muscle and eyes and gut above the temperature of the sea. That is expensive at the surface. Now drive it into water near freezing, at depth, repeatedly, and the bill goes up every single time. The heat trap has to fight harder, the oil burns faster, and there is nothing down there that looks anything like a seal. So the animal built to convert blubber into oil is spending most of its life somewhere blubber does not exist, doing something that costs it more per hour than the hunting we filmed. The reversal here is total, and it is worth saying plainly. The great white is not a coastal predator that occasionally goes offshore. It is an oceanic, deep-diving animal that occasionally visits a coastline. And we built its entire identity out of the visit. That is the ring footage problem, confirmed by satellite. Now the part that makes the offshore zone genuinely strange rather than just empty. Because when researchers started looking hard at that mid-Pacific region where the sharks congregate, a place informally known as the White Shark Cafe, the assumption was that they were crossing a dead zone, a desert, something to be endured on the way somewhere better. Then people actually went and looked. And the water was not dead. Below the barren blue surface sits the mesopelagic layer, the twilight zone, a few hundred meters down, where a huge standing mass of small fish, squid, and other animals live in the dark. It is not empty out there. The life is simply not where a human eye or a satellite can see it. The desert has a basement, and the basement is stocked. Suddenly, the saw blade makes sense as a shape. The shark is not aimlessly bouncing. It is going down to where the food is, coming back up, and going down again, which is a relief for about 4 seconds until you ask the obvious follow-up. What lives down there is small, squid, fish the size of your hand, soft, quick, scattered animals in cold black water, hundreds of meters beneath an animal that weighs as much as a car and has to keep itself warm. That is not seal food. That is not blubber. That is not the high-value payload the entire body plan is built around. And the tags cannot tell you what went into the mouth. A tag records depth and temperature. It does not record dinner. So we have an animal repeatedly diving into a layer full of small prey for months, and no direct footage of what it is doing there, because nobody has ever filmed a great white feeding a kilometer down in the open Pacific. What it is doing in the twilight zone remains one of the biggest open questions about this species, and anyone who tells you it is solved is selling something. But the constraints are brutal enough on their own. This is an animal that must eat. It has been out there for months. It is burning its liver the entire time. It is diving into cold water repeatedly, which costs more. And the only substantial food anywhere near it is small, dark, and several hundred meters beneath the surface. Whatever it is eating out there, it is not eating what the myth says it eats. Which brings the crown down to a single question, and it is not a rhetorical one. We called this species the top of the food chain based on one behavior, in one place, in one season, that accounts for a minority of its life. If we could see what it does in the other 70 or 80%, down in the dark, in the middle of an ocean, chasing things that fit in your hand, what would we call it then? Ask what a great white eats, and everyone gives the same answer. Seals, big mammals, whatever it wants, the stomachs say otherwise. Start with the part nobody puts on a poster. A great white does not begin its life as a mammal hunter. It begins as something that would not frighten you at all if you did not know the name. A newborn is a bit over a meter. A slim fish in murky nursery water off a warm coast, born into the world with no parental care, no protection, and no capacity to do a single thing the legend describes. And it does not want a seal. It could not process one. Its jaws are not built for it. Its teeth are the wrong shape, and its body is not big enough to survive the attempt. Look at those teeth. because they are the most quietly damning evidence in this entire story. A juvenile white shark does not have the famous triangle. It has narrow, pointed, spiky teeth with only weak serrations. The dentition of a fish grabber. Teeth for holding something slippery, not for cutting through a 30-centimeter wall of blubber. The most famous weapon in the ocean does not exist yet. It grows in later. So what does a young white shark do? It eats fish. Small schooling fish along the coast, rays, flatfish, things on and near the bottom, squid, other small sharks. It works the shallows and the surf zone, and it does it for years, and this is not an insignificant phase. A white shark takes a long time to reach the size where mammals are even an option. We are talking about the better part of a decade, and for female sharks, longer still. That means the overwhelming majority of white sharks alive in the ocean right now, at this exact moment, are not eating what the myth says they eat. They are eating fish in shallow water, alongside 100 other predators doing exactly the same thing. Now watch what that does to the word apex. Because a young white shark is not at the top of anything. It is a medium-sized fish in a coastal system full of larger animals, and it gets eaten. Other sharks take them, bigger white sharks will take them. That is not speculation. Juveniles are prey, and their whole early strategy is built around not being where the big animals are, which means the apex predator spends the first act of its life as somebody's lunch. So when we say a great white is at the top of the food chain, we are not describing a species. We are describing a size class, a stage, a thing an individual might get to eventually, if it survives, and most do not. Apex is not an identity. It is a resume line you can only earn late, and only if you live. Then, the shift happens. And this is where the biology gets genuinely strange, because the animal essentially rebuilds its own mouth mid-life. As it grows past roughly 3 meters, the teeth change. The narrow spikes are replaced by the broad, coarsely serrated triangles everyone knows. An edge designed for one job, which is to cut through thick, fatty tissue and take a piece out of something too large to swallow. The shark is not born a mammal hunter. It converts into one, and you can read the conversion from the outside in the chemistry of the animal itself. This is where isotope work comes in, and it is one of the more elegant tricks in ocean science. Different prey carry slightly different ratios of stable isotopes, variants of carbon and nitrogen, and those ratios pass into the body of whatever eats them. Nitrogen isotopes in particular ratchet up predictably each step up a food chain. So the tissue of a predator carries a chemical signature of what it has been eating, and different tissues turn over at different speeds, which means you can read the recent past and the deeper past in the same animal. Run that on white sharks, and the diet shift shows up in the chemistry. The signal climbs as the animal gets larger. The shark is literally recording its own promotion in its tissue, but the same tools have delivered a result that is much more awkward for the crown, and it is the reason this chapter exists. Even in adults in some populations, the chemistry does not say pure mammal specialist. It says mixed. It says fish. It says other sharks. It says an animal that eats what is available rather than what its reputation requires. And the individual variation is real. Some sharks lean heavily on mammals. Others in the same population do not, and that difference can persist. Not a species with a diet. A species full of individuals with diets. Now take that back out to the middle of the Pacific, into that saw blade dive pattern. An adult white shark, hundreds of kilometers from any coast, dropping repeatedly into cold black water, is not going down there to visit. And there is exactly one substantial food resource down there, the twilight zone. Small fish, squid, soft-bodied animals living in the dark, in a layer so dense with life it shows up on sonar as a false seabed that rises at dusk and sinks at dawn. That layer is the largest daily migration of animals on the planet. It happens every night, everywhere, in silence, and the ocean's alleged apex predator appears to be commuting into it. The honest position: nobody has filmed a great white feeding down there. The tags record depth and temperature, not dinner. What the Twilight Zone dives are for is still argued about, but the constraint is unforgiving. The animal is out there for months. It cannot stop eating for months. It is diving into the one place with food, and that food is small, which produces the reversal this whole chapter has been walking toward. Count trophic levels. A seal eats fish. A shark eats the seal. That is the pyramid everyone draws, and it puts the shark one step above the seal. Near the top, clean, satisfying. Now do a squid. Small squid eats small things. The shark eats the squid. That is a much shorter chain, and it puts the shark far lower down the ladder than the poster suggests. Same animal. Same week, possibly. Two completely different positions on the chart depending on what it happened to catch. An animal cannot occupy two levels of a pyramid at once, unless the pyramid is wrong. And here is the detail that finishes it. When a white shark eats mammals, it is climbing. When it eats fish, it is not. When it dives into the Twilight Zone and takes squid, it is eating at roughly the level of a medium fish, which is exactly what it eats when it is young. So over one lifetime, this animal moves up the food web, and then, out in open water, arguably slides back down it, repeatedly, every single night, for months at a time. There is no rank here. There is a body doing arithmetic with whatever the ocean will give it. Go back to the liver, and it all locks together. Every one of these choices is the same choice. The shark is not deciding what it wants to eat. It is deciding what it can afford. Blubber is the best return available, so when blubber is present and reachable, it spends everything on one strike and refills the tank. When blubber is not present, which is most of its life in most of the ocean, it does the only thing left. It goes down into the dark and takes small things over and over, and hopes the total exceeds the cost of getting there. That is not the behavior of a king. That is the behavior of something running a deficit. And now the thing that should have been obvious from the start. We built a pyramid, we put an animal on top of it, and then we followed the animal and found it had walked off the chart entirely. Up in one season, down in another. Sideways for a decade of its youth. The shark did not break the rules. The chart was never a real object. It is a drawing we made, with a shape we chose, for reasons that have nothing to do with the ocean. But before we take the chart apart, there is one more thing this animal does that no legend survives. It waits for something to die. A dead whale is the largest meal in the ocean, and it does not fight back. Understand what arrives when a big whale dies at sea. Tens of tons of tissue, floating, held up by decomposition gases until the body is a bloated island. And inside that island is a thick outer layer of blubber. The same substance a great white spends its entire life chasing in 300-kilogram packets attached to a seal that can see it coming. Here it is in tons, and it is not going anywhere. Now watch what the ocean's most feared animal does when this appears. It comes. From distances that are hard to comfortably explain. A whale carcass generates an oil slick that spreads across the surface and drags down current for kilometers, and the shark's sensory system reads dissolved chemistry at concentrations that mean nothing to a land animal. It does not smell the whale. It reads the plume, turns into it, and follows the gradient upstream until the water gets richer. And when it arrives, it does not attack. It feeds, slowly, for hours, sometimes days. This is documented. Great whites at whale carcasses, multiple sharks at once, working the same body, feeding until their girth visibly changes. The animal that everybody films exploding vertically out of the water at dawn, with a seal in its jaws and spray hanging in the air like a religious event, is given the option, a scavenger. And that word is doing a lot of work, so let us be careful, because this is not an insult, and it is not a downgrade. It is arithmetic. Everything we have established says the same thing. The shark is a warm engine with a permanent bill. Every hunt is a gamble. The famous strike is a single enormous expenditure with no guarantee. A seal that turns half a second early is a wasted payment. Chase, and you burn more. Miss twice, and you have spent a day's worth of fuel on nothing. Now put 100 tons of unmoving fat in the water. The gamble goes to zero. The prey cannot dodge. It cannot see you. It cannot leave. Every calorie of effort converts directly into calories of blubber, with no risk attached. If your entire body is an accountant, this is not a compromise. This is the best deal in the ocean, and any animal that ignored it out of pride would be dead within a generation. That is the reversal. The world's great hunter would rather not hunt. Hunting is what it does when nothing has died recently. But the scavenging is not even the strangest part. Watch what happens between the sharks, multiple great whites, several meters each, converging on one finite food source. Every instinct you have says this ends in violence. This is the animal we have spent 50 years describing as a rage-driven killing machine, and here are half a dozen of them, in the same water, with something worth fighting over. They do not fight. They queue. What has been observed at carcasses is not chaos. It is order. Sharks arriving, circling, taking turns, coming in and pulling back. And when there is friction, it is resolved without damage. Sharks give way to each other, and the pattern in what people have watched suggests size matters most. Larger animals feed, smaller animals wait and take their turn. There are also displays. Sharks approaching each other in ways that look less like combat and more like negotiation. Parallel swimming, a shift in posture, one animal peeling off before contact ever happens. Nobody should overread this. We cannot climb inside their heads, and there is real disagreement about how structured any of it is. How much is individual recognition versus simple size assessment, and how much varies between places. White shark social behavior is one of the least settled areas in the field, and it deserves to stay that way. But the visible outcome is not in dispute. A gathering that should be a bloodbath is instead resolved almost entirely without injury. And once again, the reason is the liver. Fighting is unaffordable. A wound on an animal that must swim constantly to breathe is not a scratch. It is a maintenance cost added to a body already running a deficit. Two great whites tearing into each other would both lose, permanently, over a meal that is large enough for everyone anyway. So they do not. The restraint is not politeness. It is the same equation, applied to each other. Now hold the image, because it is the exact opposite of the poster. A dead whale rolling in an oil slick. 6 of the ocean's supposed monsters around it, orderly, patient, taking turns, eating something that died on its own. The apex predator, standing in line. And there is a detail here that quietly reorganizes everything from the last few chapters. When a great white gorges at a carcass, it can take in an enormous load of fat in one sitting. That does not just fill a stomach. It refills the tank. The oil goes into the liver, the reserve rebuilds, the animal gets lighter and cheaper to run, which means a single dead whale can fund weeks of that offshore existence. The crossings, the Twilight Zone dives, the months in blue desert where nothing is worth eating. Scavenging is not a shameful shortcut in this animal's life. It may be one of the load-bearing pillars of it. The great white's most important survival skill may not be killing anything at all. It may be finding what is already dead before the competition does. And now zoom out, because the whale is not just a meal. It is a machine. Most whales that die do not float. They sink. And a whale carcass hitting the deep sea floor creates something with its own name. A whale fall. A sudden delivery of an enormous quantity of food into a place that normally receives a thin drizzle of particles from far above. Down there, the arrival of tens of tons of tissue is not a snack. It is an event that supports a succession of organisms for years. Scavengers strip the soft tissue. Then other things move in for what is left. Then the bones themselves become a resource, worked over by specialized organisms that live on almost nothing else. An entire local system, running on one dead animal, in total darkness, for years. So look at what the whale actually is. Alive, it is one of the largest animals that has ever existed, eating tiny things near the surface. Dead, it becomes an energy transfer, a package that takes surface productivity and drops it into the deep, feeding sharks on the way down and a whole community once it lands. The whale is not on the pyramid. The whale is plumbing. And that is the moment the diagram starts to fail visibly, because we have a great white eating a dead thing that never had a predator. We have that same shark eating squid at 400 meters and seals at 4 meters in the same year. We have juveniles being eaten by adults of their own species. We have orcas eating the shark. We have the deep sea being fed by the surface via corpses. Where do the arrows go? Which way is up? Every one of these facts is fine on its own. Put them on a triangle and the triangle stops making sense. Which raises the question this whole story has been building toward, and it is not the one you think. We have spent 7 chapters knocking a shark down a ladder, off the top, out of the bay, down the trophic scale, into the queue at a corpse. But we never checked the ladder. Nobody ever went looking for the ocean's top predator and found it. We drew a shape, decided it had a point at the top, and then went hunting for something to put there. First the shark, because it had teeth. Now the orca, because it eats the shark. And that second answer is going to fall apart faster than the first, because when you look at the animal we are about to hand the crown to, it turns out it is not one animal at all. So the crown goes to the orca. That is where everyone lands, and it feels earned. Bigger, smarter, kills the shark, takes the liver, empties a coastline. Case closed? It is wrong, and the way it is wrong is more interesting than the way it is right. Because there is no such thing as an orca, not in the sense you think. Yes, there is a species. One species worldwide, from ice to equator, one of the most widely distributed vertebrates on the planet. On paper, it is a single animal. In the water, it is not. Look at what has been documented in the North Pacific alone, because that is where the picture cracked open first. 2 kinds of orca were being seen in the same water, and at first the assumption was that they were the same population doing different things. They were not. One group eats fish, specifically salmon, and in some cases specifically one species of salmon, which they will pursue while ignoring almost everything else. They travel in large, stable, noisy family groups. They vocalize constantly. Their whole existence is organized around finding fish. The other group eats mammals, seals, sea lions, porpoises, the calves of large whales. They move in smaller groups, and they are quiet. They hunt in near silence because the animals they are hunting have ears and would otherwise hear them coming from kilometers away. Same species, same ocean, same coastline. And here is the part that stops the story dead. They do not mix. They do not interbreed. They do not hunt together. They do not appear to socialize. Genetic work says these lineages have been separate for a very long time, long enough that biologists now seriously argue about whether they should be classified as different species at all. That argument is live and unresolved and worth watching. Two animals that look almost identical, sharing water, and functionally living in different worlds. Now here's the detail that should raise the hair on your arms. The fish eaters will not eat a seal. There are seals swimming past them. Right there. Edible, fatty, defenseless. Exactly what the other group would drown in the next 10 minutes. And the fish eaters ignore them completely. Think about what that means, because it is not a physical limitation. Their bodies are more than capable. Nothing stops them except that it is not what their family does. Not a diet. A tradition. The knowledge of how to hunt a mammal is not in the genome. It is in the group. It has to be taught. And if nobody teaches you, you go your whole life beside a food source you never touch. Which is not how we are used to thinking about animals at all. That is culture doing the job that instinct is supposed to do. And the pattern is not confined to one coast. Around the world, orca populations specialize. Some populations hunt seals off beaches. Some work herring. Some take large whales. Some go after sharks and rays. Their calls differ between groups the way accents do. Specific to a lineage, learned, passed down. And these specializations are sticky. They persist across generations because each generation is trained by the last. So take that back to the beach in South Africa, to the missing liver, and watch the crown fall apart in your hands. The shark killers are not the species. They are a subset, a specific line, carrying a specific technique, in specific water. The overwhelming majority of orcas alive on Earth right now have never touched a white shark and never will. Not because they cannot, but because their family does something else. In parts of the world, orcas and white sharks share the same water, and nothing happens at all. The knowledge of how to open a shark is not distributed across a species. It is held by some number of animals, possibly a very small number, in a handful of places, which means the answer to who beats the great white is not orcas. It is a technique, held in a lineage, applied where it has been learned. And now flip the whole thing over. You cannot put a technique on a food pyramid. There is nowhere to draw it. It is not a body. It is not a size class. It is not a species. It is information moving between skulls, and it obeys none of the rules a chart is built from. It does not need a generation to change. It can be invented once and taught by the next season. It can appear in water it has never been in because somebody swam there. Which raises a question nobody can answer, and the honest thing is to say so. Is this new? Have a couple of orcas recently worked out how to open a white shark? And is that knowledge now spreading? Or has this been happening quietly for centuries in water nobody was monitoring, and we only noticed because a few carcasses washed up somewhere with roads and cameras and researchers? Nobody knows. Both stories fit the evidence. The bodies on that beach might be a new behavior or an old one finally observed. Sit with that, because it is the same failure that built the shark's crown in the first place. We saw a thing at one location, in one window, and assumed it described the world. We do not know how much of this is happening in the 80% of the ocean, where nobody is standing on the sand with a camera. And there is one more thing to say about the orca, and it undercuts the coronation from the other direction. We spent this whole story dismantling the shark by showing it gets scared, gets eaten, gets displaced, eats small things, eats dead things, cues. Fine. Now apply the same audit to the new king. Some orca populations depend so heavily on one specific prey species that when that prey collapses, they starve. Not adapt, starve. The specialization that makes them lethal makes them brittle. Their young take years to raise. Their groups are small. Their knowledge is fragile. And if the animals holding a technique die, the technique dies. A body plan cannot be lost in one generation. A tradition can. So the great predator we are about to crown is an animal whose greatest weapon, learned knowledge, is also the easiest thing in nature to destroy. That is not a king. That is a specialist with a very good idea and no backup. And here is where this chapter stops being about orcas at all. Look at what we just did. We took the shark off the top and immediately went looking for a replacement. The instinct was automatic. Something had to be up there. The chart had a point at the top, and a point at the top demands an occupant. That instinct is the actual problem. Because if the answer changes every time you look closer, from shark to orca, to a couple of orcas, to an idea a couple of orcas are carrying, then the answer was never the thing you were measuring. You have been measuring the diagram. Swapping kings does not fix anything. It just keeps the same broken shape and puts a different face on it. Every time we crown something, we are making the identical mistake, assuming the ocean has a top, and that we can find it, and that finding it explains anything. So stop looking for who wears the crown. Ask where the crown came from, who drew the triangle, why it has a point, why we have all been staring at a shape that, once you follow the arrows honestly, does not exist anywhere in the water. Because the biggest lie about the ocean's top predator was never about which animal we picked. It was the sentence itself. You have seen the picture. Everyone has. It is on classroom walls, in textbooks, in every documentary ever made about the sea. A triangle, wide at the bottom, narrow at the top, green stuff on the bottom row, small fish above it, bigger fish above them, and up at the point, alone, the shark, or the orca, whichever monster the artist preferred. That triangle is the most successful piece of misinformation in the history of ocean science, and almost nobody thinks of it as a claim at all. It looks like a fact. It looks like something that was measured. It was not measured, it was drawn. And the man who drew it was not lying. That is the part worth sitting with, because it stops this from being a story about stupidity. In the 1940s, an ecologist was trying to solve a real problem, how energy moves through a living system, and he needed a way to show that the answer is loss. Sunlight goes into plants. Something eats the plants and captures only a fraction of that energy, because most of it was spent just being alive. Something eats that animal and captures a fraction again. At every step, the overwhelming majority of the energy is gone, burned, radiated away as heat, spent on the simple work of existing. That is real, that is physics, and it does not bend. It means big predators must be rare, not because they are special, but because there is almost nothing left by the time you get up there. Draw it as boxes and you get a shape that narrows. The pyramid was not a ranking. It was a graph of energy loss. And then it escaped. Because a shape is a story. And this one told a story people already wanted. Wide bottom, narrow top, one thing at the peak. That is not a graph anymore. That is a hierarchy. It is a throne. It is a ladder. It matched every social structure humans had ever built. And so we read our own furniture into a diagram about heat loss and never noticed we had done it. The chart taught the lie better than any movie ever did. The movie made you afraid of a shark for a summer. The chart made you believe, permanently, that the ocean has a top and something is sitting on it. Now take the animal from the last 9 chapters and try to put it in a box. Which box? The newborn eating small fish in a nursery, 3 levels up maybe. The juvenile taking rays off the bottom while larger sharks eat it, prey and predator on the same afternoon. The adult exploding under a seal. Near the top of a short, fat chain. The same adult, 4 months later and 2,000 kilometers out, dropping into the twilight zone and taking squid. Back down to roughly where it started as a child. The same shark again, motionless beside a dead whale, eating something that was never killed by anything, in an orderly queue with 5 others. You need 5 boxes for 1 animal in 1 year. The arrows do not go one way. They loop, they reverse. The pyramid says a thing eats what is below it, but a big fish eats the eggs and larvae of animals that will grow up to eat it. That is not an exception. That is normal. The ocean is full of predators eating the babies of their own predators. Follow those arrows honestly, and they do not form a ladder. They form a knot. And then, the whale. The whale is the thing the pyramid cannot survive. Here is one of the largest animals that has ever lived, eating some of the smallest. Filtering animals 2 steps off the bottom of the chart. By the energy logic, it is barely up the ladder at all. Nothing hunts a healthy adult. It has no predator and no rank. And when it dies, it does not get eaten by the level above it. It sinks. Tens of tons of surface productivity falls into the deep and feeds a community for years in the dark. Where is that arrow on the triangle? It goes down. It goes off the bottom of the page. Watch the shape fail. Watch the tidy rows dissolve into arrows going sideways and backwards and down, loops that eat their own tails, and one enormous line that drops off the edge into black water. That tangle is not a failure to draw the ocean properly. That is the ocean. And here's the rule the pyramid hides, the one that actually runs the sea. In the ocean, what you eat is mostly decided by how big your mouth is compared to how big the thing is. Not by species, not by rank, size. That is why the same animal occupies 5 different positions across its life. It is not being promoted. It is just getting bigger. And the menu updates. A fish that was food last year is eating this year's version of itself. Everything is climbing the same escalator, and the escalator has no top. It just has a size beyond which nothing in the local water can fit you in its mouth. That is what apex predator actually means, stripped of the ceremony. Not king, not strongest, just currently too large to be swallowed by anything nearby. It is a statement about geometry, and it is temporary, and it is local, and it collapses the second something arrives that is bigger or smarter, or working in a group, or carrying a technique somebody taught it. That is the whole story of the beach. The great white was not dethroned. It simply met an animal that did not have the mouth problem. Now the part that should genuinely unsettle you because it is not about sharks. The pyramid has one more property nobody talks about. It has a viewer. Somebody is standing outside it, looking at it, drawing it. Every single one of those diagrams was made by an animal that put itself nowhere on the chart. Look at the classroom poster again. Plankton, fish, tuna, shark. Where are we? Not in the picture. We are the ones holding the pen. And that is the deepest layer of the lie, deeper than the shark, deeper than the orca. It is not just that we invented a top. It is that we invented a top and then quietly excused ourselves from the diagram, so that whatever we did to the ocean was never on the chart at all. We watched from outside, filmed a fish for 50 years, and called it the ruler of a system we had already decided we were not part of. So the crown was never a discovery. It was a job we created, on a chart we drew, and then interviewed candidates for. Which leaves the question this whole thing has been circling. If there is no top, and the chart is a knot, and rank is just mouth size, then who is actually removing life from this ocean? Not who wins a fight. Who does the killing at volume, at scale, every day? Count what we have looked at so far. Sharks, orcas, big things with teeth. Add all of them together, every predator in every ocean, and put that number next to the total amount of life that dies in the sea every single day. The predators do not register. Not they are a smaller share than you think. They are a rounding error. The overwhelming majority of death in the ocean has nothing to do with teeth, or hunting, or anything you could film. It happens constantly everywhere, at a scale that makes every shark on Earth statistically irrelevant. And you cannot see it. Not from a boat, not from a cage, not with a camera on a fin. You need a microscope. Take a glass of seawater, clear, ordinary. Nothing in it. There are somewhere around 10 billion viruses in it. Not bacteria, not plankton, viruses. Packets of genetic material in a protein shell, so small that millions would fit across the width of a human hair, so numerous that they outnumber every other biological entity in the sea by roughly an order of magnitude. In every glass, every bucket, every cubic meter of the ocean, from the surface to the trench floor, you have been swimming in them your entire life. So has every shark. Now, the number that should reorganize your understanding of this planet. The best available estimates suggest that marine viruses kill something on the order of 20 to 40% of the ocean's microbial life every single day. Every day. Not once. Not in a bad year. Daily, continuously, since before anything had teeth. Hold that next to the shark. Put every great white alive on Earth in one column, and one day of viral activity in the other, and the shark column does not appear. It is not small. It is invisible. Every predator in the ocean, every shark, every orca, every tuna, every squid, every animal that has ever been filmed killing anything could be added together, and the sum would still be a rounding error against what happens in that glass of water while you hold it. The deadliest thing in the ocean has no teeth. It has no body. It cannot swim. And here is where it stops being a grim statistic and becomes something stranger, because that killing is not damage. It is the engine. Think about what a virus actually does. It gets into a bacterial cell, hijacks the machinery, replicates, and bursts the cell open. And what spills out is everything that cell had spent its life accumulating. Carbon, nitrogen, iron, phosphorus, all the raw material of life, released back into the water as free-floating molecules. Now multiply that by an unimaginable number every day, everywhere. That is not death. That is a distribution system. Ecologists call the effect the viral shunt, and the name says it exactly. Energy and nutrients that would have moved up the chain into bigger and bigger animals get shunted sideways instead, back into the water, where they are immediately taken up by the next generation of microbes. Which means the ocean's dominant mode of death is not something eating something, it is something popping. And the pyramid has no box for that either. Where does the arrow go? Sideways. Back down. Into a loop that never leaves the bottom of the chart at all. The largest flow of energy in the ocean does not travel up the ladder, it circles. So the food chain most of the ocean actually runs on is not fish eating fish. It is microbes being burst open by viruses and other microbes eating what spills out. That loop handles a colossal share of the sea's total biological throughput. The big animals, everything you can see, everything anyone has ever made a documentary about, are what happens with the fraction that escapes the loop and makes it upward. We built our entire understanding of the ocean out of the leftovers. Now widen it, because viruses are not the only invisible killer. Disease runs through marine populations constantly. Parasites are so common in the sea that they are less a hazard than a condition. Most large fish are carrying passengers. In the gut, in the gills, in the muscle, in the eyes. Great whites included. The most feared animal in the ocean is a habitat. And starvation. That is the one that never gets a camera. For most animals in the ocean, the thing that finally kills them is not a predator. It is not finding enough food. It is a slow accounting failure. Exactly the failure a great white flirts with every time it crosses an ocean basin with a liver running down. Nothing bites it. It simply runs out, which means the great white and the microbe are dying of the same thing. Now go back to that glass of water and change how you see it. You have been told your whole life that the terrifying thing about the ocean is what might be under you. It is not. The terrifying thing is what is in you, around you, and through you. A fluid so saturated with biological activity that calling it water is almost a category error. The sea is not a place where life happens. The sea is alive, at a scale that has no interest in anything with a spine. And now the problem this creates, which is the honest one, and the one that could end this whole story. If viruses kill more life before breakfast than every predator on Earth manages in a year, then what is the point of a shark? That is not rhetorical. That is a real question with a real edge on it. We have spent 10 chapters knocking this animal off a pedestal. It gets eaten. It flees. It cues at corpses. It eats squid. And now it turns out it is not even statistically relevant to the ocean's mortality. It is a rare, expensive, slow-reproducing animal that removes a trivial quantity of biomass from a system that loses more than that in a heartbeat. If the numbers are what matter, the shark is decoration. So why does everyone, fishery scientists, conservationists, people who have spent 30 years on the water, insist that removing sharks breaks things? Why does a system fall over when you take out an animal that barely eats anything? Because we have been measuring the wrong thing. All of it. Every argument in this story so far, mine included, has assumed that a predator matters because of what it kills. That assumption is wrong, and it is the last big reversal in this story. Go back to False Bay. Go back to the moment the orcas arrived and the great whites vanished from the coast. What happened next? The sharks were gone. So the amount of predation on the seals dropped by a quantity that, in the grand accounting of that ecosystem's biomass, was nothing. A handful of seals a week. Statistically irrelevant. And the seals changed anyway. They spread out. They used water they had never used. They stopped running the gauntlet at dawn. They stayed out longer, went further, relaxed. Nothing about their death rate explains that. The change did not come from what the sharks were eating. It came from what the seals believed. For their entire lives, every one of those animals had been organizing every hour of every day around a shape that might be beneath them. Where they swam, when they left, how fast, how tightly they bunched. All of it was a tax, paid in lost feeding time, lost territory, lost options, levied by an animal that hardly ever actually took anyone. The shark was not controlling that bay by killing. It was controlling it by being possible. And that is a completely different kind of power. It does not show up in a stomach. It does not show up in a biomass figure. It cannot be counted by adding up bodies. It is a force that operates entirely through the nervous systems of everything that is afraid, which means the ocean's supposed apex predator matters, genuinely, structurally matters, for a reason nobody ever put on a poster, not for what it eats, for what it makes everything else too frightened to do. Watch a seal colony that has sharks in the water, and then watch one that does not. The animals are identical. The behavior is not even the same species of behavior. Where the sharks are, a seal colony runs like something under occupation. Departures happen at specific times, in groups, at speed. The animals bunch, they porpoise. That fast, low, skipping motion across the surface that costs energy and buys distance. They hug the shallows where a big shark cannot come in beneath them without giving itself away. They come back the same way. Certain hours of certain days are simply not used, and the water past a certain line is not entered. And none of this is written down anywhere. It is just what the survivors do. Take the sharks away, and it dissolves. The animals spread. They swim alone. They use the deep water. They stay out longer. They stop looking down. Nothing about the number of dead seals explains that difference. That is the point. Because if you actually count what a great white removes from a seal colony over a season, the figure is small. A handful of animals against a population of thousands. In pure arithmetic, in the biomass ledger that ran the last chapter, the shark is barely a presence. You could delete its entire annual take and the colony would not notice. And yet every waking decision those seals make is built around it. That is the mechanism, and it has a name. Ecologists call them risk effects, and the shorthand is the landscape of fear. The idea is simple, and it is one of the more genuinely important things to come out of ecology in the last 30 years. A predator does not only shape a system by eating, it shapes it by existing, because everything beneath it is constantly spending something to avoid it. And that spending is where the real force is. Look at what fear actually costs a seal. It cannot feed where it wants, so it feeds somewhere worse. It cannot feed when it wants, so it feeds at a bad hour. It burns energy on speed it does not need. It stays in a tight group when spreading out would be more efficient. It gives up the best water entirely. Every one of those is a bill paid daily by every animal in the colony. Multiply it across thousands of individuals across a lifetime, and the total dwarfs, completely dwarfs, the handful of animals the shark actually ate. The predator eats a few. It taxes all of them, which reverses the whole idea of what a predator is. We have been thinking of it as a machine that removes animals. It is not. It is a pressure that reorganizes them. The killing is almost incidental. The killing is just what maintains the credibility of the threat. The shark's real weapon is not the mouth. It is being believed in, and that is why the crown never made sense as a ranking. Rank implies the shark is at the top of a killing chart. It is not. The virus chapter settled that. But the shark sits somewhere the virus cannot reach, because the virus does not frighten anything. Nothing changes its behavior because of a virus. Nothing looks over its shoulder. That is the difference between mortality and influence, and we spent a century confusing them. Now push it further, because the tax does not stop at the seal. The seals are eating something, fish mostly, and squid, and whatever else they can get. And where those seals feed is now decided not by where the food is best, but by where the shark makes it survivable to look, which means the shark's fear is doing something strange. It is drawing a map on the seafloor that the seals cannot cross. And the fish on the wrong side of that line are living in a refuge that no shark ever visits and no fish knows exists. Fear moves down. That is the whole idea behind a trophic cascade. The predator scares the herbivore or the mid-level hunter. That animal stops using certain places or eating certain things, and the level below it changes shape. The famous version is not even a shark. It is otters, urchins, and kelp. Otters eat urchins. Urchins eat kelp. Remove the otters, and the urchins multiply and graze the kelp forest down to bare rock, a barren. Put the otters back, and the kelp returns. One animal, 3 levels of consequence, and none of it about the otters themselves. The marine version people argue about most involves big sharks, mid-sized predators, and seagrass beds. The logic being that if the big sharks vanish, the animals they used to frighten stop being frightened, graze the vegetation harder, and the habitat below thins out. And here is where I have to stop and be honest with you, because this is exactly the place where a documentary would run ahead of the evidence, and I'm not going to. Cascades are real. They have been demonstrated. Nobody serious disputes that removing a large predator can change a system. The magnitude is a fight. How strong these effects are in the open ocean. How far down they propagate, whether a given case is a genuine cascade or 2 unrelated changes happening at once, whether the shark version holds up as well as the otter version, All of that is argued about hard by people with more data than either of us. Some systems show it beautifully. Some show almost nothing. The ocean is not a laboratory, and you cannot run a control. Keep the argument alive. It is more interesting than the certainty would be. But the direction is not in doubt, and the direction is enough. A predator that eats almost nothing can still be structural. It can be load-bearing. You can pull out an animal that accounts for a trivial fraction of deaths in a system and watch the system change shape because you did not remove a mouth. You removed a rule. So look at what we have rebuilt. The great white is not the king of the ocean. It never was. It gets eaten, it flees, it cues at corpses, it eats squid in the dark, it spends most of its life in a blue desert running a deficit, and it kills a statistically meaningless number of animals. And it matters anyway, not because of what it takes, because of what its existence forces everything around it to give up. That is a far stranger kind of importance than the poster ever offered. The animal is not powerful. The idea of the animal is powerful, carried permanently in the nervous system of every seal in that bay, whether the shark is there that day or not, which is exactly what the orcas did to the sharks, one level up. The same trick? The whites did not leave because they were losing. They left because the water had become a place where something might be. Two identifiable animals with a technique converted an entire coastline into a landscape of fear, and the supposed apex predator paid the tax like everything else. The fear is the ecosystem. The bodies are just the receipts. So here is the question, and it is the one that turns this whole story. If a predator's power lives in what everything else believes about it, what happens when the fear stops? Not when the shark dies, when there are so few of them, spread so thin, gone from so many places for so long, that the seals stop looking down. When the rule quietly expires because nothing has enforced it in 10 years. When a generation of animals grows up in water, where the shape was never possible in the first place, because something has been removing these sharks, not orcas, not disease, not starvation, something that has been taking them out of every ocean at once at a scale that makes those two orcas on that beach look like a rumor. And it does not hunt with a mouth at all. Somewhere in the open Pacific right now, there is a line in the water 60 kilometers long, not a boat, a line, one piece of gear streaming out behind a vessel with thousands of baited hooks hanging off it at intervals, drifting through blue water for hours. Then it gets hauled, and whatever is on it comes up, and the line goes out again. That is one set. There are thousands of vessels doing this. Now think about what that thing actually is. It is not a hunt. There is no ambush, no pursuit, no risk, no failed attempt that costs anybody a day's fuel. It is a machine that converts the fundamental fact of the ocean, that everything in it is hungry, directly into bodies. It does not need to find the animal. It needs to wait for the animal to find it. The great white spends its entire life solving one problem: how to get enough calories without spending more calories than it gets. Every chapter of this story has been that equation. The warm muscle, the liver, the single explosive strike, the cue at the whale, the months in the desert. The long line does not have that problem. It does not eat. It does not get cold. It does not need to break even, which is the first thing that puts us outside the diagram. Every predator that has ever existed has been limited by its own metabolism. Kill more than you can use, and you have wasted energy you could not afford. That constraint is what has kept every predator honest for 400 million years. We removed the constraint. We hunt with objects. Now the numbers, and I want to be careful here because this is exactly where a story like this would reach for a big round figure and pretend it is solid. The honest position is that nobody knows precisely how many sharks are killed each year. You cannot count what happens across every fleet in every ocean, much of it unreported, much of it caught by accident and thrown back dead. What exists are estimates, and the estimates land in the tens of millions annually, with published work putting the figure somewhere in the range of roughly 100 million, give or take enormously, depending on method and year. Do not fixate on the number. Fixate on the shape of it. Take everything else in this story, every orca that ever opened a shark, every white shark that ever ate another, every disease, every parasite, every failed hunt that ended in starvation. Add all of it, across all of history, in every ocean. It does not approach 1 year of us. 2 orcas emptied a coastline, and we called it a revolution in ocean science. 2 orcas is a rumor. We are running the largest predation event in the recorded history of the group. And volume is not even the important part. This is where it gets genuinely strange, and where the word predator stops working. Every natural predator in the sea is a size specialist. That is the rule the last chapters established. What you eat is decided by how big your mouth is, which means every predator hits one slice of the web and leaves the rest alone. An orca cannot eat plankton. A white shark cannot eat a whale that is alive. Everything is constrained by its own geometry. We are not. We take the plankton, krill, hauled by the hundreds of thousands of tons. We take the small schooling fish underneath everything, ground into meal to feed animals in pens. We take the mid-level fish. We take the tuna and the swordfish. We take the sharks. We take the whales, historically, at a scale that emptied ocean basins. And we take the seafloor itself, dragging weighted gear across bottom habitat that took centuries to build and flattening it in an afternoon. Name one other animal that feeds at every trophic level simultaneously. There isn't one. There has never been one. This is not a predator sitting at the top of the chart. This is something that removed the chart's central rule, that your position is fixed by your body, and then ate every row at once. And now the part that should actually unsettle you, because it is the one thing no natural system has ever had to deal with. Look at what a predator normally takes. It takes the young, the sick, the old, the slow, the unlucky. That is not sentiment. It is mechanics. Those are the animals you can catch. A predator hunting seals takes the pup that surfaced in the wrong place, not the prime adult in the middle of the group, which means natural predation, brutal as it is, mostly removes animals the population can spare and leaves the breeders. Our gear does the exact opposite. Nets and hooks and quotas select for size. We want the big one. The trophy, the price per kilo, the fish worth landing. So we take the largest animals in every population, which, in almost every species in the sea, means the oldest, the most fertile, the ones producing the most offspring, the ones that took decades to build. We are the only predator in the history of the planet that systematically targets breeding adults across every level of the food web at once. That is not a predator. There is no category for it. Every model of how predators and prey interact, the cycles, the balances, the way populations recover, assumes a hunter with a mouth, a metabolism, and a preference for the weak. Remove all three, and the model does not apply anymore. And for the great white specifically, the timing is catastrophic in a way that has nothing to do with cruelty. Remember what this animal is. It takes something like a decade or more to reach breeding size. For females, longer still. It produces a small number of pups, live-born, after a long gestation. There is no compensation mechanism. It cannot flood the water with eggs. Its entire life strategy is built on the assumption that an adult, once it reaches size, will live for a very long time and reproduce slowly across decades. That strategy works perfectly in an ocean where the only thing that can kill a large adult is a coordinated group of orcas carrying a rare technique. It fails instantly against a hook because a shark that took 15 years to build can be removed in an afternoon by a piece of gear that cost nothing, deployed by something that was never hungry, in water nobody is watching, and the population cannot replace it on any time scale that matters because replacing it takes 15 years and a survivor. Now put the whole picture together and look at what we actually did. We took an animal, filmed 1 hour of its life, called it the ruler of the ocean, and built a cultural monster out of a data gap. We put it at the top of a chart we drew ourselves, a chart we carefully left ourselves off. We watched it flee from orcas and called that a scandal. We found bodies on a beach and called it a dethroning. And the entire time, in every ocean simultaneously, we were doing this. We called the shark a killing machine while running one. That is the biggest lie about the ocean's top predator, and it was never about which animal we picked. The lie was in the framing. The belief that the top predator was something out there, in the water, that we could point a camera at and rank. We spent 50 years asking who is the apex predator of the ocean, and the answer was standing on the boat, holding the camera. But there is a worse version of this, and it is the one that closes the trap. Because everything we have measured about the modern ocean, every population survey, every model, every stomach sample, every one of those false confidence sentences about who eats whom, was collected in the last few decades, which is to say, after all of this had already been happening for centuries. We did not study the ocean and then break it. We broke it, waited, and then started taking notes. And we called what we found normal. Every number in this story has a hidden date on it, and the date is the problem. We know roughly what a white shark population looks like today. We know how many seals sit on that island. We know what the tags say, and what the isotopes say, and what the stomachs contain. All of it is real data, carefully collected, honestly reported. All of it was collected after. That is the thing nobody puts in the caption. Marine science, as an organized activity with instruments and boats and funding, is young. Tagging is decades old. Systematic surveys of most species are decades old. Underwater film is decades old. The great white's entire scientific record fits comfortably inside one human lifetime, and industrial fishing is centuries old. So the ocean we measured was already the aftermath. Every baseline we set, every "this is how many there should be," every "this is what a healthy population looks like," was measured against a system that had already been running down for generations before anyone thought to write anything down. We arrived at the scene, took careful notes, and called the wreckage the natural state. There is a name for this failure, and it belongs to a fisheries scientist who noticed something uncomfortable about his own colleagues in the 1990s. He pointed out that each generation of researchers takes the ocean they encountered at the start of their career as the normal one. They measure decline from that point. Then they retire, and the next generation starts from the diminished ocean they inherited and calls that normal and measures decline from there. Shifting baselines. Not a conspiracy, not incompetence, a slow, quiet, generational amnesia where the memory of what was there resets every 30 years, and the effect compounds, not once, every single time. Now look for evidence outside the science, because that is the only place the older ocean survives. Old photographs, dockside pictures from the mid-20th century, sport fishing boats coming in, and the fish hanging on the rack are enormous. Animals that would be extraordinary today. And in the picture, they are routine. And the man beside them is not even smiling particularly hard. Look at the same dock now. Same species. Same pose. The fish reaches his waist. Nothing in either photograph is a lie. That is what makes it work. Both are true records of what a good day looked like 60 years apart, and the only thing that changed is what a good day means. Look further back and the accounts get harder to process. Historical records, logs, colonial descriptions, catch records, port ledgers, describe coastal waters in terms that read now like exaggeration. Fish in quantities that sound invented. Sea turtles in numbers that would make a modern population survey look like a typo. Large predators as an ordinary nuisance rather than a rare sighting. The instinct is to dismiss it as sailors telling stories. Some of it is. But the pattern is too consistent across too many independent sources, and where those accounts can be cross-checked against physical records, bones in middens, old catch ledgers, the size distribution of shells in archaeological layers, they hold up more often than they collapse. The ocean was not slightly fuller. It was a different ocean. And now apply that to the Great White specifically, because this is where the last chapter's crown falls off in the most humiliating way possible. We have spent this entire story asking whether this animal is the top predator. Every argument, mine, yours, the researchers, the films, has been conducted inside the ocean we currently have. But look at what used to be in that water alongside it. Large sharks of many species, in numbers that are hard to reconstruct, but were unambiguously higher. Whales in populations that were reduced by an order of magnitude or more before most of them were ever studied. Enormous predatory fish. Entire guilds of large animals doing overlapping jobs, competing, interfering, eating each other's young, crowding each other out of the best water. Take all of that out. Leave one species standing. The great white might look like an apex predator for the least impressive reason imaginable, because we already removed everything that used to complicate the question. That is the reversal, and it is the one that should stay with you. We did not discover the top of the food web. We deleted enough of the middle and the top that something was left standing alone, and then we photographed it and called it a king. It is not the ruler of the ocean. It is the last large thing in the room. And this is where the whole story turns into a genuine epistemological problem rather than a nature documentary, because every model we have built, every trophic cascade argument, every debate about whether removing sharks changes seagrass beds, every calculation of how much predation a system needs, was calibrated on a depleted ocean. We are fitting equations to the remains and then using those equations to predict how the system works, which means when researchers argue about the magnitude of cascades, part of what they are arguing about may be an artifact. Maybe the effects look weak in some systems because the animals that used to generate strong effects are no longer there in the numbers required to generate them. You cannot measure the influence of a predator that is functionally absent. It reads as 0. And a 0 looks exactly like proof that it never mattered. Absence is very good at pretending to be evidence. And now the emotional pivot, because there is something in here that is genuinely uncomfortable, and it is not about statistics. Go back to the beginning. Go back to the poster. The swimmer at the surface, the shape rising underneath, the whole apparatus of fear that this animal has carried for 50 years. We were terrified of a survivor. That is the shape of it. We looked at one of the last large predators left in a system we had already emptied, and we did not see a remnant. We saw a monster. We built an entire mythology of oceanic menace around an animal that was, at that exact moment, being removed from every ocean on Earth faster than it could possibly replace itself. The fear was pointed in exactly the wrong direction, and it was pointed there at the worst possible time. And the fear had consequences, not metaphorical ones. A species that the public understands as a killer is a species nobody wants to protect, And a species nobody wants to protect is a species that gets killed without argument. Fear is not neutral. Fear is a policy. So here's where we actually stand. The ocean we study is not the ocean. It is what is left of it. The baselines we defend are the diminished ones our grandparents inherited from their grandparents' diminished ones. The animal we crowned is a survivor of a purge we ran, standing alone in a room we cleared, being measured against a normal that never existed. And the crown itself, the thing this entire story has been dismantling, was only ever placed on this animal because we could not see enough of the ocean to know better. Which leaves one question, and it is not about pyramids or orcas or fishing fleets. If everything we have believed about this animal was built from ring footage, a data gap, and a system we had already broken, then what actually is it? Not the myth, not the villain, not the king. What is the animal underneath all of that? When you strip off 50 years of everything we projected onto it, strip it all off, the poster, the crown, the orcas, the chart, take everything we have said about this animal and put it aside and look at what is actually swimming out there. Start with the timeline, because the timeline is the first thing that does not fit the myth. A great white does not grow up fast. Nobody realized how slow it was until the mid-2000s, when researchers worked out that the layered bands in shark vertebrae could be dated using a chemical signature left in the ocean by mid-century nuclear testing, a global marker with a known date, sitting inside the animal's own skeleton. Line up the bands against the marker, and you get an age. The answer was not what anyone expected. These sharks live for decades. Some of the individuals examined were estimated to be in their 70s. That is a fish with a human lifespan. And then the second half of that number, which is worse. Males take somewhere around a decade to mature. Females take longer. The estimates run into the mid-teens and beyond. So a female white shark spends roughly the first third of her life not reproducing at all. She is not building a dynasty. She is just staying alive long enough to start. Now put reproduction next to it. She does not broadcast eggs into the water like most fish. The pups develop inside her, over a gestation thought to run somewhere around a year and a half, one of the longest known in any fish, and there are not many of them. A handful, maybe a dozen or so, depending on the animal, born fully formed, over a meter long, and then immediately alone. No care, no return. She never sees them again. Count the arithmetic on that. 15 years to reach maturity, 18 months to build a litter, a small number of pups, most of which will not survive their first years because everything bigger will eat them. That is not a fish strategy. That is a whale strategy. It is an elephant strategy. It is the reproductive profile of a large, slow, long-lived mammal running inside the body of a shark, and it works. It has worked for millions of years under exactly one condition, that an adult, once it gets big, is nearly impossible to kill. That is the whole bet. Grow slow, breed rarely, and survive for 50 years to make it add up. The species has staked everything on the durability of adults, which means every single thing in this story lands on this one fact. The orcas taking livers, the gear taking breeders. The decades of removal, all of it is aimed precisely at the one thing this animal cannot afford to lose and cannot replace on any timescale shorter than a human career. The most feared fish in the ocean has the fragility of a large mammal and none of the protection. That is the real vulnerability. Not that it can be killed, that it takes 15 years to make another one. Now the mind, and here we have to be careful because this is exactly where people start narrating and stop observing. The public image is a machine, something that swims and bites and does not think. It was never true, But the alternative that replaced it, the noble, misunderstood, curious shark, is just as much of a projection. Both are stories about us. What the evidence actually shows is stranger and less satisfying. Individual white sharks are not interchangeable. Follow enough of them, and you find that different animals do different things. Some lean heavily on mammals, others in the same water do not. Some make the long oceanic crossings, others do not. Personality is a loaded word, and I am not going to use it as a claim, but the variation is real, and it is documented, and it wrecks the idea of a species with a single behavior. There is no such thing as the great white. There are thousands of individuals doing thousands of slightly different things, and we average them into a monster. And the approach, that famous slow circle before contact, the one that gets narrated as menace, as toying, as cruelty. Look at it from inside the animal's problem instead. It is an animal that must not waste a strike, cannot afford injury, cannot risk a bad decision on a body that has no reserve outside one organ. What looks like stalking is closer to inspection. It is checking. It is an expensive animal deciding whether the thing in front of it is worth the payment. Even the bite that gets described as savage is mechanically often something else. Sharks have no hands. They have one sensory instrument capable of resolving texture and structure, and it happens to be lined with teeth. When a white shark bites something unfamiliar, then leaves it, then does not come back, that pattern shows up over and over in the record. The most parsimonious reading is not bloodlust. It is that the animal checked, got its answer, and left. That is not affection. Do not make it affection. It is a fish doing arithmetic with the only tool it has. But it is not the poster either. And the fear is worth one honest number. For all the mythology, attacks on humans are statistically vanishingly rare, not zero, not harmless. When it happens, it is horrifying, and pretending otherwise is dishonest. But the scale of the fear and the scale of the risk have never been in the same universe, and they never were, not even in 1975. So here is where both directions collapse at once. We were afraid of the wrong thing. We spent 50 years terrified of an animal that almost never touches us, that flees from orcas, that cues at corpses, that eats squid in the dark, that takes 15 years to grow up and then dies on a hook it never understood. And we were not afraid of the right thing. We were not afraid of the fleet, the gear, the 50-year removal of every large animal from every ocean at once, the actual event, the one with the numbers. The one that has been running the entire time we were pointing cameras at seals. The fear was misassigned in both directions simultaneously. That is the cost of the crown. It made us frightened of a survivor and comfortable with ourselves. Now look at the animal one more time, honestly, with all of it in place. A warm-blooded fish that must burn its own reserve to stay warm and stay afloat. That stores its entire fortune in one soft organ behind the pectoral fins, which is also the only reason it does not sink. That crosses ocean basins alone through water with nothing in it. That drops into the dark, hundreds of meters down, over and over, for months, chasing things smaller than your hand. That runs from what it cannot beat. That waits for things to die. That takes 15 years to reproduce once. That lives, if it is astonishingly lucky, as long as you will. That is not a monster. It is not a king. It is not a machine. It is an animal running one of the most expensive survival strategies in the sea, on the thinnest margin, with no reserve and no second chance. And it has been doing it, successfully, for longer than there have been humans to be afraid of it. The lie was never that the great white was dangerous. It is dangerous. It is a large predator, and it will do exactly what a large predator does. The lie was that it was in charge. And there is one thing left to say, because the crown never actually belonged to the shark, And it never belonged to the orca either. It has never been out there in the water at all. It has been in the room the whole time, with us, in the shape we drew. Go back to the beach. The body is still there. 5 meters of it, laid out on the sand at low light, gulls working the edges. Intact. The teeth still perfect, the fins still standing, the whole silhouette that has frightened people since before you were born, still exactly, uselessly intact. And one opening between the pectoral fins. You know what took the liver now. You know it was probably a small number of animals carrying a technique somebody learned and taught. You know the organ was a fuel tank and a flotation device in one soft, undefended mass, and that removing it undoes 15 years of arithmetic in a few minutes. But look at what is actually on that sand, and it is not a dethroning. It is a receipt for a crown that never existed, because we went looking for the biggest lie about the ocean's top predator, and every candidate turned out to be too small. The lie was not that a movie made us afraid. It was not that we picked the wrong animal. It was not even that the orcas beat the sharks. Because there is no orca, only lineages, only techniques, only a handful of individuals in specific water carrying an idea that could vanish with them. The lie was the sentence itself. The ocean's top predator. 4 words that assume a top, that assume a single occupant, that assume the question has an answer, and that finding the answer would tell you something. It doesn't. It never did. We drew a triangle to describe how energy leaks away as heat, and then we read a throne into it, because a throne is what we have always drawn. Then we spent a century auditioning animals for a job that only exists on paper. Follow the arrows honestly, and they not. A shark that is prey at 3 and predator at 15. A whale with no rank that dies and drops the surface into the deep. A virus with no body killing more life in a morning than every predator on Earth manages in a year. A shark eating squid in the dark at the same trophic level it occupied as a child. There is no ladder in that water. There is a size rule, a lot of hunger, and an enormous amount of luck. And the animal we crowned was never at the top of anything. It runs. It waits for things to die. It cues. It takes 15 years to make one more of itself, and it spends most of its life in the emptiest water on the planet, dropping into the cold, burning its own reserve, hoping the arithmetic holds. It matters anyway. Not for what it kills. That number is nothing. It matters because everything around it organizes its entire existence around the possibility of it. Its power was never in the mouth. It was in being believed in. That is the strangest thing this story turned up. And it is the one thing the poster got backwards in the most complete way possible. The shark is not frightening because it eats. It is important because it frightens, which is exactly what we took away. Now the last part, and it is the one that does not let anybody off. Look at the classroom poster one more time. Plankton, fish, tuna, shark, neat rows, clean arrows, and no human being anywhere on it. That is the trick, not the animal we put at the top, the animal we left off. We drew a diagram of the ocean and quietly excused ourselves from it, so that everything we did to that system happened somewhere outside the frame, in a place with no arrows and no accounting. And then we watched from the boat and called the fish a killer. There is no natural predator that hunts every trophic level at once. There is no natural predator that targets breeding adults across an entire web. There is no natural predator that was never hungry, never cold, never limited by its own metabolism, never forced to break even. Every constraint that has kept predators honest for 400 million years, we removed all of them, and we removed them with objects. That is not a top predator. There is no category for it. And the reason we never noticed is that we were busy holding the pen. So no, the crown did not pass from the shark to the orca. The crown fell because there was never a head it fit. And the thing that took it has been in the water the whole time, not swimming, floating. 60 kilometers of line and a few thousand hooks, drifting through blue water in the dark, waiting for the ocean to be hungry. Here is the last image, and I want you to sit in it. Black water at night, somewhere out past the shelf. Hundreds of kilometers from land. No moon on it, nothing on the surface. And somewhere below, a shark that has been swimming for 4 months, dropping into the cold and coming back up, over and over, running down the oil in an organ it cannot refill out here. Above it, a satellite catches a tag ping. 1 pulse, a few bites. That is all we have. Not the animal, a signal from it. A narrow beam of data crossing an ocean we ranked, filmed, feared, and emptied before we understood a single thing about it. The shark was never lying to us. The chart was.